Yes, today we are going to know about the Davvison and Germer's experiment. I'm gonna explain about this experiment, and we know that de Broglie have explained that the moving particle is associated with the matter waves, and Davvison and Germer, who are the two well-known scientists who got the proof from this experiment to explain the matter that moving particle is associated with the matter waves. Here this is known as the electron gun, and this is the filament which is made up of tungsten material, and this is battery. And when the filament is heated or tungsten is heated, then the electrons are produced from the tungsten material, and these are the electrodes which are placed two sides of the gun because to accelerate the electrons which are passing through the filament or tungsten. And when the electrodes are placed here, the electrons passed from this filament will be accelerated, and due to this acceleration the electrons will pass with a fine narrow slit and narrow beam. And this is a nickel crystal. Every crystal contains a nickel crystal arrangement, nickel plate. It consists of a crystal arrangement. So when these electrons are fall onto the crystal, then it reflects the Faraday cylinder, which is the circular shaped scale. Here, when the electrons are accelerated by giving the different types of potential differences, the electrons will fall on the nickel plate and then reflects to the cylindrical scale. Here when they fall on the cylindrical scale, they will form by making the different angles. And when they fall on the cylindrical plane, they will show the deflections in the galvanometer, which is already connected by the cylindrical scale. And the crystal clear point is that when the two types of electrons, that means the fast electrons which are produced from the tungsten material and the secondary electrons which are produced from the crystal arrangement of the nickel crystal, will fall on the cylindrical scale. But the cylindrical scale will allow the electrons which are fast moving, but they reflect back the electrons which are secondary electrons. And when the fast moving electrons fall on the cylindrical scale, they will form deflections in the galvanometer, which is already connected to it. When more number of electrons fall on the cylindrical scale, then the galvanometer will show more deflection and vice versa. So by these more and less deflection, it can be said that the particle is associated with the wave nature. The main drawback is that we cannot determine the electromagnetic radiation produced by the fast moving electrons. Thank you.